Not every job needs the biggest model on the block, and right there is one of your biggest cost levers. The slide puts them head to head. On the left, the LLM, the large language model, billions of parameters and broad capability. Look at its strengths: broad knowledge across domains and languages, high capability on complex tasks, versatile across many use cases. It's the brilliant generalist, but drop down to the cost row. Highest capability, yes, but also the highest compute and memory cost. It wants GPUs at scale. On the right, the SLM, the small language model, fewer parameters, focused, efficient. Its strengths read differently: built for specific tasks, efficient enough to run on CPUs or modest accelerators, and private by design because it keeps data close to where it's used. And look where it lives: on-prem, edge, even a local device. Lower compute, lower memory, lower cost. Now the heart of the slide, bottom left, right-sizing the model is a real cost and performance lever. That scale icon is the whole point. Choosing the right model for the right job optimizes both outcomes and spend. If a tuned small model nails the task, you do not burn a giant LLM's resources to do it. That's not cutting corners. That's engineering discipline. Look at the guidance on the bottom right. Reach for an LLM when you need broad knowledge and reasoning across complex general tasks. Reach for an SLM when you want efficiency, speed, privacy, and local or edge deployment. Think of it like hiring. Sometimes you need a world-class generalist consultant who can tackle anything, and you pay for it. Other times you need a sharp specialist who does one job fast and cheap, right there in your office. Same logic. On the exam and on the job, know that trade-off cold LLMs for broad, heavy lifting SLMs for focused, efficient, distributed deployment, because that single choice ripples straight into how much infrastructure you have to buy. Let's tie the two worlds together and then look down the road. Panel 1. Traditional AI, it classifies and decides based on existing data, and the big virtue is it's explainable. You can trace exactly why it did what it did. Panel 2, Generative AI, it creates brand new content, but it's less transparent. Those decisions are much harder to trace back through the network. Neither one replaces the other. They're tools for different jobs. Now panel 3 is the one that hits your budget. Generative AI needs far more. Look at those side-by-side bars: compute, memory, and fabric bandwidth, all dramatically higher for generative versus traditional. That note underneath says it plainly. Gen AI training and inference at scale demand orders of magnitude, more resources. That's not a small step up. It's a different league, and it's the whole reason this certification exists. Panel 4, the trend line. This is where you future-proof yourself. 3 things to watch: multimodal models that handle text, images, audio, and video together. Smaller, more efficient models, that right-sizing push we just talked about, and agentic AI, where models don't just answer, they take actions to achieve goals on their own. The workloads are evolving fast, which brings us to panel 5, the takeaway for you: infrastructure must flex to keep pace. Look at what that means concretely. Elastic compute that scales on demand, high-performance memory feeding the GPUs, a high-bandwidth fabric, intelligent storage, security built in, and observability with automation. Here's the lesson: don't design for today's exact model, because next year's will be bigger, multimodal, and more autonomous. Design for change. Build a flexible, high-performance foundation, and you can ride whatever AI throws at you next. All right, let's pause and make sure these fundamentals stuck. Quick gut check before we move on. 3 questions right there on the screen. Question 1. What's the key difference between machine learning and deep learning? Take a beat. The answer's in the cards. Deep learning uses multi-layered neural networks that learn features automatically, while classic machine learning usually needs a human to do the feature engineering. Question 2. Which workload is more compute-intensive, traditional or generative AI? Look at that compute intensity gauge. Generative AI. pinned at the very high end. It's the one driving all those GPUs. Question 3. When would you choose a small language model over a large one? When you need lower latency, lower cost, privacy, or edge and on-prem deployment. And the task is focused. If those 3 landed cleanly, your fundamentals are solid. If one wobbled, scroll back. It's worth it. Now let's get into what people actually do with all this.